Hello there and welcome to the June 2019 paper. Here we're looking at question 7. So f of z equals z cubed minus 8z squared plus pz minus 24, where p is a real constant. Given that the equation f of z equals 0 has distinct roots of alpha, beta and alpha plus 12 over alpha minus beta, solve completely the equation f of z equals 0. So let's get started then. So what we want to use is those sum of roots formulae. I think if we use the first one, which is the sum of alpha equals minus b over a, then we'll add our roots together and get minus 8 over 1. So it's going to be alpha plus beta plus alpha plus 12 over alpha minus beta. So that's adding up all our roots together, equals minus b over a, which is 8 over 1, so equals 8. In this has actually worked out quite nicely because that will cancel out our b's, so I'm going to get 2 alpha plus 12 over alpha equals 8. We could divide by 2 here, so alpha plus 4 over alpha, so divided by 8 will give us 6, divided by 2 will give us 6, equals 4. Let's now times by alpha, so it will be alpha squared plus 6 equals 4 alpha. Let's now move the alpha onto the other side. You get alpha squared minus 4 alpha plus 6 equals 0. Let's now go ahead and solve this in the polynomial equation solver, and we get 2 plus root 2. So alpha equals 2 plus root 2. I, and without loss of generality, the other root, which is 2 minus root 2i, we can just set equal to beta. 2 minus root 2i. Now, how do we know that the 2 minus root 2i is not the other one? Well, you could do that as well, and you would get exactly the same value for the next root that we're about to get. So if alpha is 2 plus root 2i, 2 plus root 2i, plus 12 over 2 plus root 2i, and then minus beta, which is 2 minus root 2i. And if we put all of that into the calculator, then we get beta equals, putting that all into the calculator, we get beta, we get 4. 4 is the answer to this calculation here. That would effectively be this root here. So this root here is 4, and these two roots are 2 plus root 2i and 2 minus root 2i. And we'd expect that from the cubic. We'd expect 1 real and 2 imaginary at most. So there we are. And if you were to try it the other way around and put this root here as 2 minus root 2i and then work out beta, then you would get beta as 4. So it doesn't really matter which way around you've done that. So your roots here are 2 plus root 2i, 2 minus root 2i, and 4. These are your 3 roots. Moving on to part B now, hence find the value of p. This is going to be the sum of the doubles equals c over a, which in this case will just equal p over 1, so p. So we'll add these up doubled, so 2 plus root 2i, and then 2 minus root 2i, multiplied together, add 4 lots of 2 plus root 2i, and then add 4 lots of 2 minus root 2i. So let's expand with the brackets, and we're going to get 4, and then it's going to be 2 root 2i and minus 2 root 2i. Then it'll be root 2 times root 2, I times I, minus I squared is 1, so that'll be plus 2. That would be then 8 plus 4 root 2i, and then plus another 8 minus 4 root 2i. Add all these together. 4 plus 2 is 6, plus another 8 is 14, plus another 2 is 22. So there we are, that's the answer to the value of p. P equals 22, and that's the answer for question 7 there. So not too much there. You always do lots of checking there. And what you could do now is you could go to the polynomial mode on your calculator and type in z cubed minus 8z squared plus 22z minus 24, and equals 0, type that into your polynomial solver and hope that you get these 3 roots out of your cubic equation, and then you can check that you've done that question right on the calculator. So there we are. That's the answer for question 7 there, 8 marks worth in total. Let's now move on to question 8.